Hey, and welcome back to another Learning Java 2D game programming video. So in our last video, we started generating our map. So currently, we only generate some water, and sometimes, like this time, that becomes quite a lot of water, and sometimes it doesn't. So it's very random. Um, in today's video, we are going to be making roads. So we are going to make use of the pathfinding algorithm that we already have to create some natural looking roads from various random spots to various other random spots. So hopefully that will come out pretty okay. So let's get to that. First thing I'm going to do is hop over to our map generator. And currently we have this generate patches, and then after everything, we auto tile our map. So now we want to generate the roads in between here. So I'm going to say generate roads. And let's pass in how many roads we want to generate, and these are most likely going to go into each other, so it's not going to look like distinct roads. And I guess that's not the point either, but rather when we generate the road on this map, how many times do you want to generate something between two positions? So anyway, I'm just going to start by saying 5. And we probably need to tell it. Let's do it. We've been sending the game map first, right? And then the amount, and then from which tile we want to do. And that means we need to make a dirt tile. I'm going to call it dirt, new tile with the sprite library, and dirt, and true. You can walk on this. All right, so let's just use the dirt here. And let's generate this method. Number of roads. Yeah. All right, so what is it that we want this method to actually do? Well, we want to first, let's do a for loop. So for int I is equal to 0, I is less than number of roads, I++. So we want to randomize a start position and an end position. So I'm going to say position start is equal to game map get random available position. And let's do the same thing for the end. All right, and then I'd like to get a list of positions, like usual, from the pathfinder. Find path, and we do start, end, and we send in the game map. So now we have a path on our game map with the water pools from a random start position to a random end position. So now let's generate a road between these positions. So I'm going to say path dot for each position. Let's do a double for loop. So for int x is equal to position grid x minus 1, x is smaller than or equal to position grid x plus 1, and x plus plus. Do the same for the y. All right, so for every path, every position tile that became a dirt tile in this case, we want to look at all of its 8 neighbors, and we want to turn those into dirt tiles as well. And the reason why we want to do that is because our art does not support if there's only one tile of dirt, right? There needs to be at least 2 tiles next to each other, or rather 4 tiles actually, for it to become anything with the art that we have. But really, to get a wide road like the ones that I use in my regular map, it needs to be 3 dirt tiles next to each other. So that's why we're doing this. So whenever we're placing a dirt, we're actually making the 8 tiles around it also dirt. So now let's just check if it's within bounds. And then let's make this one set tile at x and y to a tile.copy of the tile that we sent in. So this should generate a road for us. Now let's try that out, see what that looks like. All right, so as you can see, things didn't go all too well since this body of water completely separated these islands. So let's try that again. This went a little better, but as you can see, probably several of these random positions were very close to each other. And this one was over here, which makes you think that it started here. It tried to pick a position over here maybe, and that didn't work. So therefore it just didn't do anything. That's when we send back, if you remember, our pathfinder, if it can't find a valid way to the other path, the end path, the target, then we just send back the start path, and that's what has happened in this case. So as you can see here, it just became one long road here across everything, and I think that's kind of fine. This looks sort of interesting. Just going to turn off the grid here and look. So like this is working for us, and it's making quite like okay roads. I think they are looking a little like squarey, but that also has to do with the way that our art is made. So our maps are always going to be a little bit square, but I still think that it made quite fun maps here. And so sometimes there aren't very many roads. So what I'm just going to do is I'm going to increase the number of roads that we are making. So I'm going to say 20 and see what that looks like. So hopefully it's not going to make it like so that there's too many roads, because many of these roads are probably going to be generated sort of at the same spot. I mean, this became quite a large. All right, so maybe 20 was a little much. Not gonna lie. That was maybe a little much. Let's try 10. All right, so now you got this natural little roundabout down here, and sure, why not? Absolutely, I say why not? And I mean, this was an interesting map that it made with these little pools all over here. As you can see, it might still do things like this, so we're going to have to go through our map and clean it up. So if we notice that there are things like here where we can't support this. So if this tile would have been grass, then this would have been an edge tile that would have been fine. So we would have had to cross this edge tile. Or sorry, this water tile. We would have to make that a grass tile. And so that's probably something that we are gonna do now. Let's clean this up. Question is, do I auto tile before or after? I'm not sure, because maybe we want to use the fact that tiles that we can't auto tile, they become the base tile. So I probably want to use the fact that they become a base tile. So I'm probably going to do the cleanup after we auto tile, but that probably means that later we're going to have to auto tile again. So here, let's do cleanup. And I'm going to give it a game map, and I'm going to first give it the type that I want to clean up, so we don't have to look at everything at once. We want to clean up the water tiles because they're the ones that look weird. So when we remove a water tile, we want it to be grass. So let's define a grass tile. Which means we don't have the sprite library here. We need to send in the sprite library. There we go. Grass, and it is walkable. So this should just be called tile. There we go. All right, so just like before, I'd like to check for each of these loops. I want to check if we made any sort of cleanup. Maybe changes have been made. I don't know if that name is clear enough. We'll have to think about that. But so we're doing a do while loops because I absolutely wanted to at least check the entire map once to see if it finds anything. So we're doing this while changes have been made. So if we first loop through all of the map and we fix some stuff, then we want to loop through it again to make sure that those fixes didn't introduce any new weird things. So we're doing another round of cleanup until we have looked through the entire map and cleaned up nothing. So the double for loop. In here, let's just find what is the tile that we are at. So I'm going to say tile current tile is equal to game map get tile at x and y. And then if current tile dot is same type as the tile that we sent in and should be cleaned up. So let's put this in its own method because we're going to do some checking. So if all of this is true, then we want to set game map to tile.copy of grass. So if it should be cleaned up, then we're going to make it grass instead. And that means the changes have been made is equal to true. So at the end of each of these loops, we need to auto tile because we are probably going to look at that base tile index and should be cleaned up. So let's just do that. And let's create this method so we can find out whether it should clean up. I'm just going to call this position actually. So what do we want to do here? Well, the fact is, I feel like now we need to know how many neighbors are the same tile type as this one. And we don't have a method for that, but we almost have a method for that. So we're going to actually make a change to that. I'm going to say int number of neighbors of same type, maybe. I'm going to say that is equal to number of neighbors of same type. And we send in the game map, the position, and the tile. So we don't have this, but we have something very similar, which is this has orthogonal neighbor of same tile. And that's really what we're interested in here as well, because we can't really handle diagonal tiles, so that's not what we're interested in. We want to know how many of them are orthogonally adjacent to our tile. So instead of saying has, let's just say get number of. Oof. And now this will return an int instead. So I'm going to say int number of orthogonal neighbors. So many hard words. I'm going to start at 0. So instead of returning true, I'm just going to say number of orthogonal neighbors plus plus. And let's do that here as well. And then return number of orthogonal neighbors. So here we're doing has orthogonal neighbors of same tile. Let's just get them and see if they're more than 0, and then this will mean the same thing. But now we can use it up here to get the number of orthogonal neighbors of same tile. There should be an S in here. There we go. All right, so now we have the numbers. And we should clean it up if we only have one. If it's just one, then as we talked about before, there's no way for us to connect those two using the art that we have. So this is not a valid case. If we only have one orthogonal neighbor, then clean us up, please. But there's also another case. So if the number of neighbors of same type is equal to 2, and both of those neighbors are on the same axis. That means that we are, let me just, I'm just gonna comment this out so that I can show you. And it's sad, so let's just return false. All right, I'm just gonna show you what I'm talking about right now. And I'm gonna turn on the auto tile so you can see. So here is a water tile. And if it has 2 neighbors, but they're both on the same axis, that would look like, oh, sorry. Jesus, not like that. That would look like this. And there's still nothing that we can do to fix that. It needs to be like so. So in this case, this would be true for the first case. This one only has one orthogonal neighbor, which is this one. So this one would be cleaned up. That one would become grass. Oh. But in the case that we have 2 orthogonal neighbors and they're both on the same axis, then we also want to clean that up. So let's fix it. Both neighbors are on the same axis. We're going to pass in the game map. We're going to pass in the position, and we're going to pass in the current tile. And then let's make a new method of that. So how do we know if we're on the same axis? Well, first, let's get the grid positions out so that we can use them more easily. I'm just going to say X because we're going to use it for a couple of checks. So the X is position grid X, and Y is the position grid Y. Now, if game map get tile X minus 1 Y, let's see, is same type as our current tile, and game map get tile X plus 1 and Y is same type as our current tile, then both of the neighbors are on the X axis. Either if this is true or if the same but for the Y is true. I'm just going to copy this and switch out the minus and pluses from the X to the Y. Yes, there we go. So either if both of the neighbors are on the x-axis as our current tile, or both of the neighbors are on the y-axis of our current tile, that means that both neighbors are on the same axis. So hopefully this will also do that cleanup. All right, so let's try that again. See if first of all, if it works and what it looks like. All right, we may not need to do this. Let's just remove that for now. This is what I missed. When we go in here, we of course need to set changes have been made to false. So that means that this is redundant. Otherwise, if we made one change, this is going to be true. So this loop will run forever. That is bad. All right, let's try this out a couple of times and see if it cleaned up all of those things. And we don't really know, so we're just gonna have to test it out and see if everything looks okay. And here is one that it didn't. Actually, it cleaned it up correctly. It did not auto tile it. And that's because we removed the auto tiling from here, which is good because we ended up not looking at the type of tile anyway, which means let's just do it down here instead. And actually, that means we probably don't need to do it there at all. So this should be better. All right. So sometimes they become two big islands, and we might need to take care of that somehow eventually, but I'm gonna not do that today. But as you can see, now we are getting some basic terrain, we are getting some water, we are getting some dirt, and I'm fairly happy with this. We could play on most of these maps. So in the next video, we are gonna start adding some scenery automatically. So, oh, look at that. We may need to fix that somehow. This never happened in any of the other ones. All right. We'll handle edge cases. That doesn't happen very often, so I'm not going to focus on that just yet, but that could happen. All right. Thank you so much for watching, and I will see you soon. Hej då.